All right, back on track. Here we go. Okay, so yeah, we're adding and subtracting and multiplying polynomials. Uh-oh. My marker is dying. Marker is dead. Okay. So I'll do 2 examples, and then I'll have you guys try 2, okay? Because again, it's not too crazy, I don't think. So the directions you're going to get for stuff like this will be something as basic as like just to simplify. This one's dying too, I think. Directions will be something as basic as simplify. What that really means, is to like combine like terms. Okay, stuff like that. Okay, so let's do an example here. All right, so we'll say 4x squared minus x to the third plus 2 plus 5x to the fourth. Okay, plus negative x plus 6x squared plus 3x to the fourth. So what operation am I asking you guys to do here? Add, subtract, multiply, or divide?
Add.
Add, right? Yeah, the plus sign between the 2 sets of parentheses there, that's your clue, right? That's your the clue, that's what you're supposed to be doing here. Okay. So since there's no numbers in front of the parentheses here, right? There's nothing in front of these parentheses, there's nothing at the end of these parentheses to distribute, you can kind of like imagine just like dropping all these parentheses, right? Just like imagine they're not there, and we're just going to combine like terms. That's it. Okay? So do you guys remember what makes terms like? Like what do you look for when you're looking for like terms?
Terms are the same.
Okay, same variables. And what about the variables?
They're negative and positive.
Okay, it could be negative or positive, that's true. But more importantly, though, the variables not only have to be the same, but they also have to have the same what? Exponents, that's right, okay? So, let's go here to, oops, that's like way...
Couldn't you, not do that by just making a change by, 4 times x times 4 times x times 4 times x?
So for this one,
To get rid of the exponents?
No, we're not going to get rid of the exponents because that x squared, right, we can't really get rid of it. I mean, it would be x times x, right? Only the x is being squared there, and there's no way to multiply the 2 x's without knowing what x is, right? We just leave it like that. Did you want to hit the bathroom? So, go ahead, sorry. All right, so let's go to our like terms here. All right, let's go to Destiny. Destiny, if you see any like terms here when we go to combine stuff.
What, first?
Sure, yeah, no, just in general, anything, right? Because we're adding these 2 things together. So sure, we can look in the first set of parentheses. Is there anything like in the first set? No. How about the second set? Nope. Well, now we're going to add them, right? So we're going to think about adding things from each set. So is there anything like with that 4x squared, for example?
Wait, what's the other one?
Yeah. Mm-hmm.
Yeah, the 6x.
Right, exactly. Yeah, we're going to add these 2 together, right? Okay. So 4x squared plus 6x squared is going to be 10x squared, right? Notice the exponent does not change, right? If I have 4 oranges and I add 6 oranges, I now have 10 oranges, right? The oranges don't change when you add. It's just how many of them that you have when you add, right? So 10x squared, the variable does not change there. Okay? All right. Give me some more like terms here. Destiny, are there any more?
Yeah, well, 5x.
Okay, 5x to the fourth, and?
And the 3x.
Very good. And it's, again, a positive 5, positive 3, so we add that together and we get 8. X to the fourth. Okay, so we took care of those. And I like to cross them out as I go just because, it makes it easier to organize. Any other like terms here, Destiny? What's that? No, that's right. So what do we do with the rest of these things?
Add them to the problem.
Yeah, we just kind of bring them down, right? Just kind of bring them down along with the rest of the problem here. So I'll have a minus x to the third, I'll have a plus 2, and I'll have that minus x.
Why
Okay?
does that x always go last where it says like it's minus x because it means it's 1?
So I'll talk about that here. It would be minus 1x, yeah. Right. This is not the normal. So this is a fine answer, right? Based on the directions that we were given, this is a fine answer. But if we wanted to, sometimes the directions might ask you to put things in standard form. So I'll put that in quotes here. If you're asked to write your answer in standard form, that means you do it from highest degree or highest power to lowest power. Okay, so let's go ahead and let's just practice that right now. Okay, putting this in standard form from highest power to lowest power. Okay, so let's see here. We'll go to Jake K. Jake K, what is the highest power you see here?
4?
Yeah, 4. So we're going to put that out first. So it'll be 8x to the 4th. Okay, then what's the next highest power?
Negative x squared.
Yeah, yeah, there you go, minus x to the 3rd. Very good. Okay, and what next?
10x squared.
10x squared. Okay, and then after that?
Minus x.
Minus x, very good. And then last?
2.
Yeah, the plus 2. Okay, and that would be your final answer. If you want to give all of your answers in that standard form, that's fine. Okay, if you just want to do it every time, I probably will be doing that just because force of habit, But you don't have to. But I mean, yeah, I'll probably be doing that just out of force of habit. So
what if you tried to do a GCF for those? It would not work.
correct. There is no GCF. Yeah. Yeah. But again, we're not trying to factor here, so you don't have to worry about GCF right now. We'll worry about GCF at a later date when we're factoring and stuff. Okay. All right. Very good. Let's try another one. We'll do a subtraction, and then I'll have you guys try one on your own. Sure. Go ahead. All right. 12x to the 3rd plus 5x minus 8x squared plus 19 minus 6x squared minus 9x plus 3 minus 18x to the 3rd. Okay. So, what operation are we doing here? Subtraction. Okay. So, what I would encourage you to do is when you have subtraction, okay, is to distribute the subtraction sign. Okay, distribute that subtraction sign. Okay, so I'll use a different marker here just to see it. So it'll be like that. That negative, right, will multiply with all 4 of those terms there. Okay, the negative will multiply with all 4 of those terms. And so it becomes plus a negative 6x to the 2nd, a positive 9x, a negative 3, and a positive 18x to the 3rd. Okay. Once you distribute that subtraction sign, then this becomes an addition problem. Okay, and you can just follow what we did before, where we're going to just combine like terms. Okay, so I would always encourage you, whenever you have a minus sign in front of parentheses, distribute the minus sign, right? Make this add, and we'll just add the opposites and make all these the opposites there. Okay. So, Michael, what are we going to be here? What are our like terms here? Zoom in some for you maybe there. So let's just start with the 12x to the 3rd. Is there anything like with that 12x to the 3rd?
Yes.
Yes,
Well,
what?
not-
Sure, but just in general, in the problem here, for us to add together.
Yeah.
Yes, the 18, yeah, right? Okay. And again, we're adding. So it's 12 plus 18, so that'll be 30. Okay. Right. And then how about the 5x? Is there anything like with the 5x there, Michael?
Yeah.
What? Yeah, 5 and 9, so that makes 14. Okay. How about the minus 8x squared?
Yeah.
Yeah, what else?
Six.
Yeah, negative 6x squared. So negative 8 and negative 6 makes negative 14x squared. Another negative 14 there, or 14 there. Okay, anything else like?
Yeah. The 19.
Yeah, 19 and negative 3 makes a positive 16. Okay, so there it is. And again, I'm going to rewrite this in standard form. So 30x to the third minus 14x squared plus 14x plus 16. But again, this is a fine answer too. This is a fine answer.
Are they ever going to be that easy on the test?
Yeah, they will be this easy on the quiz and the test.
Good God.
What's that?
Dang.
I am not fibbing. Okay, I am not fibbing. No
That-
fibbing. Here, I'm going to give you 2 to try.
That'll be an easy A.
I hope so, but not all the problems are going to be adding and subtracting though either, right? We're going to do
So it'll
multiplication.
be multiply.
There's graphing you still have to do, but yes, there will be problems just like this on the test and on the quiz. No fibbing. Okay, so here's one for you to try, and I'll give you another one here too.
Mr. Wade, would you call me for set today?
I can. Mm-hmm. All right, so there's that one.
What's above the 3x?
It's the 11th.
Oh.
Of course. Okay. I'm going to zoom out some there. Sorry, you know what I'm going to do instead? I'll just put the other one underneath. Make it easier so I can zoom in. Sure. Yeah, 3x to the 11th. Yep. Mm-hmm. Okay, there you go. Now I can zoom in on this some so you can see it a little better, hopefully. All right, so do the addition, do the subtraction. Okay, do the addition, do the subtraction. Again, your calculator will help you a little bit, but really, ideally, you want to try and get.
When you're multiplying numbers with exponents, don't you just add the exponents?
When you're multiplying, you add exponents, yes. And we will be doing that here in just a second.
Yeah, I just wanted to double check.
But for right now, yeah, you just need to combine like terms. That's it. We're able to see. You could say, so if you have a negative 9 plus a 9, that makes 0. So you could write 0 x to the 4th if you wanted to, or you could just eliminate it because it's gone, right? So. That's good. About time, right? Enjoy it while it lasts. No, I'm just kidding. Hopefully it will continue. Well, a lot of the other stuff we've been doing so far, we can use your graphic calculator for it too, so that's helpful as well. This one you can't. I'll give you like 1 more minute here and we'll go over this. 1 more minute.
What's our goal?
It'll be out of the book and it'll be probably conversation like this.
I wish I could go to this, so I could start.
Oh, you want to start? Well, we're not done yet though. We still have to do multiplication and stuff. That's important.
I already know how to do it.
Oh, okay, perfect.
Yeah.
Okay, I see what you're saying now. Okay, very good.
Yeah, you actually want to see if I could get a little bit more ahead with the rest of it.
Again, use your graphing calculator. It helps you a lot. You just got to type it in. If you have any questions about how to use a graphing calculator, let me know. I can get your homework there.
Mr. The reason I asked was because I feel like I know how to do the multiplication.
Oh, okay. All right. Well, we'll see. We'll see. Don't worry. Maybe time to work on your homework. Don't you worry. All right. Let's go to Lindsay. Lindsay, how about number 1 here, where we're adding?
Do you want the answer or do you want
Let's yeah. Let's just give me the answer. Go ahead.
So I got 3x to the 11th.
3x to the 11th. Yeah, there's nothing like with that, so we'll just take care of that one. Okay. And then what next?
6x to the 6th.
There we go. Plus x to the 6th. And again, that's the only x to the 6th term we have, so we can cancel that out. Yeah. What else?
Plus 4x to the 4th.
Plus 4x to the 4th. Okay. And again, that was the only x to the 4th that we had, so that one's gone.
Minus 9.
Right. So here we actually had some like terms here. Minus 8 minus 1 makes minus 9. So minus 9x. And then the plus 17. You got it. Okay, perfect. And she even put it in standard form for us. Is that necessary? No, I didn't specify, right? But if you want to, that's great. Okay, it's a good habit to be able to do. You know, a thing you want to do. Okay. Highest power, next highest power, next highest power, next highest power, smallest power. Okay. All right. Great job, Lindsay. Let's go to Hannah. Okay. So we have the minus sign in front of parentheses. Let's take care of that first. When I have the minus in front of parentheses, I want to distribute it here, right? So this negative 9x to the 4th becomes positive. Positive 6 becomes negative. Minus 31 becomes positive. All right, tell me about some like terms here, Hannah.
What I have done is that, sorry, I scribbled them out.
Sure. Sure.
So I got 23x to the 7.
23x to the 7. So far, so good. There's nothing like with that.
And then plus 6x to the 7.
Okay, plus 6x to the 2nd. Okay. Or negative 6x to the 2nd, right? Because it was a negative. Okay, sorry. And then you said plus 32. Very good. Okay, yeah. The negative 9 and the positive 9 x to the 4ths, right? Those are exact opposites. They cancel out. So they go away. If you want to put a plus 0x to the 4th, you're more than welcome to. But I think this is the way to go for sure here.
So write that down. Because that's the 4.
So, okay, question.
The first one, how do you like the order to come on? Like, would it matter?
The order doesn't matter according to, because the only directions I really gave you were just to simplify. If the directions say put in standard form, that's when you know that you have to go from the highest power to the next highest power to the next highest power to the next highest power, and then you see the coefficients? Yeah, so no, it's the powers that we really want to try to order things by. So that's yeah. Does that make sense now, Michael? You see it here too? 7 is the highest power we have, then 2, and then it's a number. So that was the case.
Okay. Did you write plus on it?
I did. But a plus and negative is the same thing as a minus, right? So either one's okay. Okay? But yeah. That's one. All right, are we ready for multiplication?
Yeah.
Yeah, let's do it. Okay, so multiplication can be, I don't want to say trickier, maybe trickier, I guess we'll say. But let's briefly talk about multiplication here before we get into some polynomials. All right, so and come on, multiplying. Okay, I'll start with the very basic couple, like one or two first. I'll start with one or two basic ones here first, just because I want to make sure we're okay with this. Okay, so here I've got two polynomials that are being multiplied, the 5x and the 6x to the third. Okay, those are actually more specifically called monomials, right? Monomials because they each have a single term, right? There's no addition or subtraction, so that's all one thing. That's all one thing. Okay. Now, you guys might already have an idea about how to multiply here. So, what would this be? You think when I multiply these two things together, what are we going to get for our result?
30x to the 4th.
30
X to the 4th.
x to the 4th. Very good. That's right. Okay. When we multiply, and just so I can show you this here, 5 times x is just 5 times x, right? And then 6 times x to the third is 6 times x times x times x, right? That's what's really happening here. And you don't have to write this out if you don't want to. You don't have to show this in your work or anything. But I just want you guys to be able to see like what's really happening here, right? So when you multiply things like this, and I expanded out the x to the third to be x, x, x like that, okay? When you multiply things, you can rearrange the order and it still give you the same thing, right? 2 times 3 is the same thing as 3 times 2. So I'm going to rearrange these so that I put my two numbers together and I'll put all the x's together. And there's our 30, right? 5 times 6. There's that 30 that we got. And then there is the x to the 4th that we got right there. Okay, 4 x's multiplied together is x to the 4th. 5 times 6 gives you 30. And that's where we get our final answer right there. Okay, easy peasy, right? Let's try another one here. Okay, that's one thing, right? It's all one big product there. And we'll multiply that with that. Okay, so we're looking at this one right now. What's our coefficient going to be when we multiply here?
It's going to be a
Negative
negative
10, right? Negative 2 times 5, yeah, negative 10. Okay, so that took care of the negative 2 to the 5. It'll be x to the what power?
10. It'll be x squared.
Yeah, just x squared, right? Because we don't have any x's over here, so just x squared. The y, though, will be to what power? 6.
6.
Right, 4 plus 2 we add. Okay? And then what will it be? Z to the...
Z squared.
Yes, z squared. Z to the 1, right? When there's no exponent written, you can give it a 1. So z to the 1 plus 1 is z to the 2. Okay? And then we're done. Okay? We're not done yet. Sorry, we're done with that. I got two more I want to show you, Bobby. I'm going to have you guys try one on your own.
I think we did this in
That's why I want to do that.
Because
Because today I don't have a lot.
I think he's seen this last year.
Yeah, probably. I mean, you definitely saw it. You've seen it a couple times if you've taken like Algebra 1 and Algebra 1.5 for sure.
I think I definitely remember seeing
The
this
intro to
Chris
algebra
doing
too.
There's
this.
a class called
It's
It's an intro to this class.
Yeah, we as a shortcut we call it Algebra 1.5. It's called Intermediate Transitions to Algebra, or they also call it ITA algebra.
And then you go over all of
ITA,
this.
yes.
You go over all of this
Yes,
to get you
yes.
ready for when you do it.
It's for students that if they took Algebra 1 their freshman year, Geometry their sophomore year, and they're not feeling so confident about jumping right back into Algebra again, they take that ITA class that help prepare them then to take Algebra 2.
That's a 2 semester.
That's what it is. Because sometimes people have trouble, because it's been a while, they forget stuff, they want to get
I
warmed
got so
up,
used to
basically.
geometry, I forgot a lot of my algebra.
All right, now, here's where things change a little bit, right? Here we're multiplying a binomial, 2 terms, times another 2 terms, right? So you guys have a shortcut you can use for this, FOIL, right? F-O-I-L, it's called a mnemonic device, which I'm going to spell it out here for you. Okay, that's, you say it's got an M and N next to each other. It's like one of the craziest, words you'll ever see. I think because it comes from Greek. Mnemonic device. It's like Roy G. Biv, right? You remember the colors of the rainbow using Roy G. Biv? FOIL helps us remember how to multiply two binomials together. Okay, but really the biggest thing, because FOIL only works for certain situations, the bigger thing to remember is that every term here has to multiply with every term here, and FOIL just helps us to remember that. So 2 times 1, 2 times the x. 3x times the 1, 3x times the x is what you're going to do here, right? So 2 times 2 times 1 is
2.
2 times x?
2x.
2x, okay. So that took care of the 2 with these two. So now we'll do the 3x with both of these. So 3x times 1. 3x, right? Yep, something times 1 is always going to be itself. And then 3x times x?
3x squared.
3x squared. Exactly right. Okay. Is that the best we can do, or is there more I can simplify here?
There's
Like
more.
the 2x and the 3x.
2x and the 3x are like terms. So I'll finish off. I'll put the 3x squared first because, again, I'm trying to put it in standard form. 2 plus 3 is 5x. And then we get the plus 2. And there is our final answer right there. Okay? Another way to do this, if you just want another way to organize your work here, some people make like a chart. And they'll do like the 2 plus 3x across the top and like the 1 plus x down the bottom. And they'll kind of divide up across the addition signs, right? So they'll draw a line through this addition sign, through that addition sign, and then it kind of tells you, okay, for this cell right here, we're going to multiply 1 and 2 to get 2. And for this cell, we'll do 1 times 3x, so 3x. For this cell, we'll do 2 times x, so 2x. And for this cell, it'll be x times 3x, so 3x squared. And then you just combine all these things together.
With addition.
Or you can see, yeah, with addition. So 2, 2x, 3x, and 3x squared. You can see them all there. And so you get that as well. That helps you organize your work too. But it's your choice how you would do it. What was that? Sorry.
That doesn't seem too hard.
Yeah, if you want to just use it to help you organize your work. Okay. I'll show you one more here, and then I'll have you guys try one on your own. Okay, so now we're going to have a binomial times a trinomial. 2 terms times 3 terms. Okay, so again, each one of these will multiply with each one of these. Okay, so x is going to multiply with the 1, the minus 4x, and the 2x squared. The 2 will multiply with the 1, the minus 4x, and the 2x squared. Okay, so x times 1,
X.
x times minus 4x,
Minus 4x squared.
x times 2x squared
2x
to the
to
third.
the third. Very good. And then 2 times 1. And so that took care of the x's, right? X times 1, negative 4x, and 2x squared. That took care of all the ones we had to multiply with x. Now we'll multiply everything with 2. So 2 times 1?
2.
2. 2 times minus 4x?
8.
Minus 8x. And then 2 times 2x squared?
Well, 4x.
4x squared. There we go. And then we combine like terms.
There's
And I'm going to put it in standard form. So 2x to the third will go first. So I'll take care of that. We have a minus 4x squared and a plus 4x squared. So what happens there? They cancel. That's nice. Okay, and we have the minus 8x. Oops. I made a mistake already. Doggone it. 2x to the third. Minus 8x and a plus x. So minus 7x. And then plus 2. And there is our answer. Okay?
Now, if it doesn't say simplify, we don't need to simplify it all the way down.
You should simplify. You should combine like terms. It should say simplify. It should say. But you should simplify anyway. Just for good practice. All right. Here's one for you to try. 3 plus 2x times 4 minus 7x plus 5x squared. Okay, so go ahead and multiply those two together. Obviously, the bigger the polynomial, the more pain in the butt it is to multiply it out. Okay, the worst I'll do for you guys is a trinomial with a trinomial. Okay, where there's 3 terms and 3 terms. But for this one, I just gave you a binomial with a trinomial. Okay. Anyway. Do your best there. Multiply it out, combine like terms. Now we start on the home. give this one a try. I'll give you like 30 more seconds here. 50 more seconds. All right, let's go to Matthew. Matthew, were you able to get this multiplied out here? All right, so 3 multiplied, what'd you multiply the 3 with? So yeah, 3 times 4, and then 3 times the minus 7 there, and then 3 times the 5x squared. Okay, so let's see what that's going to give us. So 3 times 4 was 12. 3 times the negative 7, negative 21x, very good. And then 3 times the 5x squared. Yeah, 15x squared. Perfect. All right, let's go to someone else there, Matthew. Thank you. We'll go to Garrison. And then the 2x multiplied with the, the minus 7x. And what else? The 5x squared. And the 4, too, right? So 2x times 4 there, Garrison, is 8x. 2x times minus 7x squared. Or, sorry, 2x times minus 7x. Negative 14x squared. There you go. That's right. Yeah. Okay. And then 2x times the 5x squared. 10x to the third. There you go. Yeah. Cubed, if you like. All right. And then combine like terms. All right. We'll go to somebody else here for that. Let's go to Liana. Help us out here, Liana. What are our like terms now at this point? I'll start with the 10x to the third. Do we have anything like with 10x to the third? You can look at my problem. Is there anything else that's like with 10x to the third here? No. No. So we'll write that one first. Okay. And then next, let's go to the x squareds. Do we have any like terms with x squareds?
15 and negative 14.
There you go. 15 take away 14 is going to be 1. So plus 1x squared. Okay, that's gone. All right, any other like terms?
Negative 21 and 8.
Very good. So negative 21 and 8 is going to be negative 13. And then I'll do plus negative 13 there because I messed up. Okay. And then we're left with the 12, so we'll just bring that along for the ride there. There it is. There's our final answer. Okay. Questions on any of that? Anyone need to see it down at the table or anything? All right. Let's get you guys started on your assignment then. All right, so in the book,
page 203 to 204. I want you to do numbers 2, 7, 8, 13, and 19. And then on page 212 to 213, I want you to do numbers 2, 6, and 10.
On what? On page.
So right up here on the board.
Okay.
Okay. I have to do 2 different sections because we kind of covered 2 sections today at once. Okay. For number 10, additional instructions here: set up but don't simplify. That's only for number 10 on the page 213.
I can't see the number.
I'll pull off on it there. Okay.
What is it? 2, 6, and 7.
2, 6, and 10 for the page 212 to 213.
Okay. Okay, so let's get those books cracked open here. I gave you a good 15, 20 minutes to get this started. Okay, some of you guys might be able to finish.